Hello everyone. Today we're going to assemble the motor control shield with the power system adapter board. First of all, let's take a look at this battery box. We can open this battery box according to this arrow. Later, we will assemble this part. We will put the cover aside for now. Next, we will assemble this laser cut board A3 with the motor control shield as shown here. For this, we will get 4 countersunk screws along with 4 or 5mm copper pillar. Let's have a look. Let's first pass it through. We can first use our hands to screw in. And roughly fix them in place. We'll use tools to tighten them later. These 4 holes are the same as the 4 holes in the Node MCU. We won't be using this middle one, but only use these 4 holes for assembly. Once assembled, we have screws passing through to fix this. So these 4 screws may not be used for fixture later. So at this moment, you can first use your motor control shield to align these 4 holes for the time being and check if it really fits in. This one is okay. We need to fix this in place first. However, we will have to dismantle it later since we need to leave room to assemble the battery box. When screwing them down, we want the screws to practically be screwed flat, because this motor control shield needs to lay flat on it. Screw it in to the point it's almost flat. How flat should it be? To the point that when you touch it, it feels that it barely protrudes. That will be enough. When you're done, we can remove this board. Next, we're going to install the battery box. When you're doing this, you only screw 1, 2, 3, these 3 holes. Why don't we screw in this hole? Because this place will interfere with the circuit board, so we will leave that hole to avoid causing problems to the circuit. We'll get 10mm countersunk screws, and we will use nuts to fix them in place. Roughly fix these 3 screws in place for now. Afterwards, we will align flat to the side of the board during our process later on. We can now screw them tight. Reach in with the screwdriver to screw them. When screwing these, we can first use our fingers to roughly fix the nuts in place. For this step, we are not going to screw them tight yet. When screwing, you should not screw in one single screw completely tight. You should take turns to screw in all 3 screws in place first, and then tighten them. After they are positioned in place, then I screw them tight. My habit is not to screw them tight in the second round because at this time I'm still using my fingers. When they are all mostly in place and there is not much problem, then we take out a set of pliers to assist in fixing the screws in place. Then we screw them tight. How tight should the screw be? It actually has to do with experience. You screw in to the point that you think it's tight enough and then screw in for a further 15 degrees. You can use your hand to pull on it. It should not be loosened at all. If the overall thing is sturdy, then it's okay. If you screw in forcefully, of course you can still screw it, but you may cause damage to the board. That's why you need to handle it in moderation so that it's sturdy enough when it's installed. Next, we will install this motor control shield. When assembling this, a slight deformation may occur, so you may need to use a bit of force to assemble it on or move it around its relative position, so that the 4 screws can fit into the 4 holes. The troublesome part for these 4 locations is that it may be a bit hard to use the nuts to fix the screws in place at these 2 locations. We will only screw at 2 points, this one and this one, these 2 on the left. We'll grab these 2 nuts Then this one. This place is harder to screw in, so we may need to use tools. You can use a Phillips screwdriver to screw in slowly. Since it gets stuck at this place, you can loosen this part and use a bit of force to shift the whole board downwards. When I push down, you will see the board slightly shifts downwards and the space for the nut will be freed, and now you can screw in the remaining screw. When using force, you may need some skills to do so. First, you have to put the nut in place. You can grab a set of pliers to put it in place. Slightly push down the board and turn the screwdriver. This screwdriver is too big. I'll change it to a smaller one for better operation. Remember to press down the board and slowly screw in. Once it's tightly fixed, let go of the board. It can get stuck at this place, so you just need to screw it tightly enough, more or less like this. The key lies in this one. You can use the assisting force of the pliers to screw it tight. Into position. Once you think it's tight enough, turn a few degrees more. That's enough. This step is now finished. Let's move on to the next step. Hello everyone. The lesson we are having today is soldering the motor. First, let's take a look at the things we have on the table. I will introduce them first. This is a zip tie. The zip tie will be used to fix things in place. This is a capacitor. We call it a tantalum electrolytic capacitor. The main function of this capacitor is to suppress what we call a solder spark, which is generated when the motor is running. The advantage of this is that it can prevent the commutation spark from generating when the autonomous vehicle is being used, which can cause the control board to work improperly. Next are these two TT motors. This is a 30 centimeters long DuPont line. We don't need to pay attention to the color. You can separate the colors if you want to. For this class, there is no special requirement regarding colors. First of all, let's take one of the wires and use this, a wire stripper. You can use the wire stripper's rounded section to cut the wire. If you don't have a wire stripper, you can use diagonal pliers. Both of them can be used, but we still recommend that you use the wire stripper for wire stripping, because it avoids possible damages to the copper conductors. If it's not available at school, we can use the diagonal pliers instead. The diagonal pliers also have a wire stripping function. Some of them are designed with a hole. When stripping the wire, this hole can help in the process. Let's take a look at this wire stripper. Let's take one end and cut it. After cutting it, we can leave the cut off part aside. Remember to throw it away later. We're going to strip the wire and leave about 3 millimeters length, not too long. We'll use the smallest hole diameter and leave out about 3 millimeters. Place the wire inside the gap between one of these holes. Then use your thumb to pull the wire out. Use your fingers other than index and ring fingers to tighten the wire. After that, use the thumb to pull the wire out. And the copper wire exposed is approximately 3 millimeters. You can have it longer if you want, it's just that it will be harder to trim. Leaving out 3 millimeters is enough. We'll strip the other end of the wire as well. In the same way, we place it in the gap, fix it in place, and then pull it out using your thumb. The other DuPont line is prepared in the same way. First, cut the wires. Afterwards, fix the wire within one of the gaps of the wire stripper. Then use your thumb to push it away. We'll do the same for this one. Once you're done, you won't be using the wire stripper anymore, so you can put it aside. Slightly organize the copper wires and use your hand to twist them. After twisting them tight, the next step is this. There is the number 104 on it that represents its capacitance. We will put the tantalum capacitor pins inside the motor's copper wires that are located at its head. When you pass it through, pay attention to this. Many students tend to forget about this. The metal pins of this capacitor and the metal part of the motor can cause a short circuit, so you should arrange the pins to make it more organized and no excess of the pin sticks out. After we are done soldering, we will clean up and remove the excess portion of the metal pin. Let's grab our DuPont line again. Likewise, place them into these two holes. After we pass the pin through, we more or less fix it in place like this, and then we do the soldering. Let me explain the details when you are soldering. When the wire and the copper terminals of the motor are joined together, we'll use solder to solder them together and fix them at this location. Doing this, we'll first use the temperature of the soldering iron to increase the temperature of these 3 points that we want to solder, and then add solder. For the whole process, the heating time should not exceed 5 seconds. Finishing it 3 to 4 seconds would be ideal. What is considered finished? During the soldering process, you can see that the solder will melt very fast. Whenever you see that the solder is melted, you can pull the soldering iron away. If you continue to heat this part, it will overheat. So let's take a look here. You can ask your classmates for help, or if you're familiar with it, you can do it single-handedly. First, you have to fix this in place. When you are soldering this part, here comes a question. Is the temperature of the soldering iron hot enough? You can touch the solder first. You'll see that smoke is coming out. Since there is smoke, you have to be careful during the process and do this in a ventilated place. The correct way is to wear protective goggles because during the soldering process, high-temperature solder may splash around. There are 2 key points. First, work in a ventilated place, and second, wear protective goggles during operation. When we were testing the solder by melting it, some excess came out and got attached to the soldering iron. You can wipe it off onto this humid sponge and clean it off. To avoid having too much solder adhering to the soldering iron for more convenience, dip a little bit. The purpose of this is that this is a metallic object, and using melted solder at this location, its conductivity rate will be faster. The whole soldering process should not take more than 3 to 4 seconds. You have to be quick. If it takes too long, the object may overheat, and some issues can happen. Approach the soldering iron, then approach the solder, and then remove the hand. It's about this much time, just a few moments. First, check if the soldered point is fixed. Check with your eyes to see if it's okay, then use your hand to pull it and see if it moves. If it doesn't, then it's complete. The whole process was completed in 3 to 4 seconds. If it takes too long, the parts may get damaged. We'll do the same for the other side. Pass the copper wire through. Before you use the soldering iron, you must always clean out the dirt accumulated on the tip first. You must keep it clean. Next, dip a bit first, but it's okay not to do so. Dip a bit first, then count to yourself 1, 2, 3. Approach the solder, then take it away. The process is more or less like this. You can check if the solder has soldered the parts you wanted. Slightly pull the wires in the capacitor. When doing so, if it doesn't break or move, then it means it's done correctly. You can take a look at the solder. It has a slight glow, which is a more ideal finish. Having some glow means that cold soldering did not occur. Next, we need to cut off the excess wire. Why do we have to cut it? Because if you keep them, these metallic parts may get in contact with the motor's metallic shell, and it may cause short circuit. When it's done, we'll take the zip tie and use it to fix these wires in place. When using the zip tie, look at its appearance. One side is more flat, while the other side is more prominent. When we are passing the zip tie through, we do it from the flat side. Don't pass it through for real. Once through, you won't be able to pull it back. It's reversible, so you have to be careful. When you're passing it through, you check it's okay before you do so. Let's bend this over, then pass the zip tie through. Like this. When I pass it through, it's on the flat side. Then pull it out from the protruded side. After pulling it tight, it should look like this. We can place the head of the zip tie around here so that during assembly, it doesn't obstruct the assembly of the other parts. We'll fix this part onto the other side. Next, we'll use diagonal pliers or a wire stripper to cut off the excess wire. We're finished with one. We're going to work the other one as well. It's the same way for this other motor. Let's have a look. Organize the motor's copper plates a bit. Then organize the capacitor pins. We pass this through. When doing so, try to spread out the pins so that they don't have the chance to get in contact with any other metallic parts. Let's put this aside first. Slightly twist both DuPont lines. This way, when passing the wires through, they won't bump with the copper terminals. Pass one side through and do the soldering. The steps are the same as earlier. Let's first fix these three parts that I want to solder in place. First things first, we clean up the dirty parts on the soldering iron. For the next step, you can work together with a classmate and have someone to help you hold the solder. Next, dip a bit of solder. A small dip is more than enough. It will help with a faster heat transfer. Contact for 1, 2, 3. And done. When finished, slightly pull on the wire. Don't pull it right after you're finished. You have to wait for the temperature to cool down. Afterwards, check if the soldering is done correctly. After this part is done correctly, we'll connect the other side. By the way, after soldering, some students blow on it to help lowering the temperature. Don't do this. Let it cool down on its own. There's no need to do anything to cool it down, because by doing so, you may cause cold soldering. After soldering, check that this part is complete. If the soldering looks good visually, then check by pulling on the wire. If there is no problem, we'll use a zip tie to fix it all in place. Likewise, pass the zip tie through from the flat side. Then pull it with force. If female students don't have enough strength to pull this, you can use pliers for assistance. When pulling this, you should fix the head in place with your hand while using pliers to pull the other end with force. Use your finger to fix the head in place, and then pull the other end with force. If it doesn't turn around, then it is complete. Next, we take out the diagonal pliers and cut off the zip tie excess. After cutting the zip tie, don't forget that these metallic wires also need some arranging. During this process, If you didn't cut the DuPont lines short enough, and they're a little bit too long, they may get in contact with the motor, so you need to trim that as well. By observing, if you think that there is a chance that it contacts with any other parts, then you must trim them to avoid any chances of short circuit. We are finished with this part. What we're going to do next is assemble the moving platform. First, let's check the materials used. Please take each of these parts according to this order. This is an Omni wheel, and this is a motor mount, and 4 25mm copper pillar, 2 countersunk screws, 6 nuts, 4 30mm screws. We also have some special screws that we will use later, which are called SEM screws. They have an anti-slipping washer and another kind of washer which can prevent loosening due to vibration caused by the moving vehicle. From within our parts, let's pick the Omni wheel, as well as 2 10mm countersunk screws and 2 nuts. Pay special attention to this Omni wheel. Due to the vehicle's height, we need to pass it through from this side for assembly, instead of this way. This is the incorrect way of assembly. We need to place it like this. Let it slide through completely. The Omni wheel has a little bit of bending at its mounting bracket. This is not a big deal. It may cause slight deformation of the vehicle, but it doesn't matter. After we are done passing this through, use your middle finger and index finger to hold the nut. Then screw in the bolt. After slightly fixing it in place, we'll grab the nut with our fingers and then use a screwdriver to screw it tightly. After roughly screwing both bolts in place, use pliers to clamp on the nuts and then screw it tight. After screwing this into place, then turn an extra few degrees more, and that's it. This part needs a bit of experience. When operating the vehicle, if you feel that the screws are loose, then you screw them tight. Over time, you will know how much you need to screw in for it to be considered tight. For upcoming lessons, you must often check whether the screws have loosened or not. When this is done, we can place this in the middle of the table. We will use it later. We will take our TT motor, 4 30mm long screws, and 4 nuts. We also have 2 motor mounts. After I take all these things out, let's first assemble this. When assembling this motor, the capacitor should be face inward. The protruded part of the TT motors should face outward. This is for both motors. The capacitor should face inwards, and the protruded parts should face outwards. You see that there are 2 screw holes in our motor mount. These need to be fixed at the bottom. When you are assembling later, remember that the screw holes are facing down. Let's do the following assembly. We pass through the screws inwards from the outside. After passing them through, roughly screw in to fix them in place. We'll do the same for the other motor. Remember that the screw holes are facing down and the capacitor should face inside the vehicle. Pass the screws through from the outside onto the screw mount. Then use your hand to fix the screw in place. After fixing in place, we can screw them tight. Then use pliers to hold the nut. After screwing in completely, then turn a few degrees more and check that it's screwed tightly. Don't screw it too tightly. If you do so, you can damage the motor. Be careful about this. However, you can let it too loose. If you do, it will not be easy to screw in the motor mount. So you have to pay attention to this. Later when we want to screw this onto the vehicle, it won't be that easy to do. So at this moment, you must ensure that the fixture points are completely screwed in. After it's done, we need to place it in this manner. We need to check if this side is aligned flat. We need to pay attention to this part during the assembly process. Let's take out 4 SAM screws. You can see that the SAM screws are quite peculiar. It has a washer and an anti-slipping washer combined together. This will not get loosened. The advantage of this kind of screw is that there will be vibration when you are operating this autonomous vehicle, which will cause the screws to loosen. Over time, the car will become more and more unstable. If we use the SAM screws, they have an anti-slipping function. When there is vibration, they have the advantage of preventing the screws from loosening. That's why we use this kind of screws. These 4 holes at the bottom of the chassis, used for screwing the motor mount, have a tight dimension. Why? Because we need to ensure that the wheels of the motors are on a straight line. So the holes to screw in are of the right size. We'll first screw in these 4 SAM screws. When screwing these screws, you need to pay attention to the following. When some students are doing this part, they may find it difficult to do it. During the screwing process, if you find that the screw is slipping and you cannot actually screw it in, do not force it. Maybe your screwdriver is not compatible with this screw. So you have to take a look. For example, this screwdriver and this other screwdriver, they have a different size, so you have to pay attention to this. For the screwing process, you have to choose the right screw head, and don't think that because they are all screwdrivers, then it's more or less the same. So you just pick any random screwdriver. You need to take this into account. When you're done, let me remind you that the capacitor should face inward and the protruded part of the TT motor should face outward. After aligning it in place, you can then screw it in. When screwing, you must pay attention to the following. When you're pushing in and you find that the motor mount is not being pushed out, it means that your holes are aligned. So pay close attention to this when doing so. When you're screwing in the screws, and you see that it's screwing in but the motor mount is being pushed out, it means that you didn't align the holes with the motor mount. We'll roughly fix them in place. How much should these SAM screws be screwed in? You can take a look at the anti-slipping washer. The washer is originally bent up, and you can screw it until the screw and the anti-slipping washer are completely flat, which means that your SAM screw is completely screwed in. Next, we will do the same for the other side. When screwing this, we roughly align the holes. At this time, it would be hard to get a good view, so you need to be careful when doing this part. When screwing, you can have a look. If your motor is not being pushed out when you're screwing in, it means it's okay. If it's being pushed out, it means that your screws didn't pass through at the correct position, so you have to pay attention to this. When screwing this part, the design here is a fit dimension, because I need to ensure that the wheels are in a straight line, so the holes over here are cut with an exact fitting dimension. This will result in the need to be very precise when screwing this, because it would be a bit tight. If you choose a wrong size screwdriver, you may cause damage to the screw. So you need to pay attention and choose a screwdriver with the right size. When screwing into place, you can see that the anti-slipping washer is pressed down flat. The assembly part is done correctly. Next, we need to screw in the 4 copper pillar. We need to use this kind of SAM screws with an anti-slipping function at all the locations that might get loosened easily. This way is better. We'll roughly screw these 4 parts first. We don't screw them tight yet. We will do it later. After putting on the cover, we will roughly screw them in place for now. There's no need to use the screwdriver yet. When you're done, you will see that the Omni wheel is a bit warped. This warping is actually caused by the Omni wheel. It is related to the quality of the Omni wheel bought. If the surface is relatively flat, then the warping will not be that serious. It doesn't really affect our assembly process, because we left some spacing for it. Next, we will assemble another section of the moving platform. We would like you to take out the wooden board A1. Two 10mm long countersunk screws, 6 10mm SAM screws, and 4 30mm long copper pillar. These countersunk screws are quite peculiar. Let's assemble them first. We need to screw these countersunk screws in two places. Since the locations for the countersunk screws have a bit of interference with the TT motor, that's why we use the countersunk screws to avoid issues during assembly. We will first screw in the countersunk screws in these two locations. After screwing them in, we will use the SAM screws next. Afterwards, we can grab pliers to hold the copper pillar and screw them tight, because later we won't be able to screw them tight since it's facing inward and it won't be possible to screw in the nuts. We need to screw this part tight. Screw in until the SAM screws are flat. Next, we will assemble them together. We screw in these anti-slipping screws. When doing so, you already are experienced and know that when fixing the screws, remember that not only you need a twisting force, but also a downward pressure, so that when screwing in, the degree of biting will be better. So in addition to twisting, you also need to add a slight pressure. This way the screwdriver and the screw fixing will be more stable. Otherwise, many students tend to break the screw head when screwing in because they did not add a downward pressure. We should take turns to screw these in tightly because they are already set in place. Along with these, we can also screw tight the 4 parts that haven't been screwed tight yet. Since it's already in place, we can check whether they are crooked. If they are not, then you can screw them tight. Now we can move on to the next step, which is to assemble all these parts together. We have 2 wheels for the TT motor and 4 SAM screws. First, let's put these things aside. When fixing this to the motor, notice that the shaft of the TT motor is quite special. It is round with 2 sides shaved off. You can see that the TT motor's wheels also have the same shape. When you're assembling onto it, these 2 parallel edges need to be aligned and then pushed in. The first time you're pushing in, you'll need to use a bit of force. However, notice that after you push it in, it will be hard to remove. Check that you've finished all the steps. When you're pushing inwards, you can use your other hand's middle finger to push the TT motor to ensure that it is pushed in fully. Turn it over and do the same. The parallel sides should be aligned with the wheel, and then push it in tightly. Likewise, put your middle finger in to hold the motor in place and use the thumb to push in the TT motor's wheel tightly. This way it's complete. Now we can take this motor control shield and battery box controller apart and assemble them. For this assembly, there are actually 2 ways to do so. The first one is having the side of the battery box switch aligned to the edge. You can assemble it this way, or you can also do it the other way. Because when designing this vehicle, we can divide it into 2 parts. If we were designing a mechanism, it will be designed in this area, opposite to the TT motor. Therefore, we can place the switch facing towards the back. If you want to add a sensor, then you can turn this around and this space will be freed up for the sensor. Later during assembly, we will be using the mechanism approach. So we will place the sensor here. There are 2 ways of assembly. Let's explain this again. If you want to add a mechanism, the switch will be placed close to the TT motor's side. If you're going to add a sensor, your switch will be placed on the side opposite to the TT motor. We'll fix this in place first. We'll assemble the mechanism part later. So we will assemble it this way. When fixing the screws, do not screw in at once. We fix these 4 screws in place first and make sure they are in the correct position. What does the correct position mean? It means that this board's expected position already meets our needs. It is aligned correctly. Then we screw in tightly. When we're screwing this board in place, we can still adjust its position slightly to make it align to certain surfaces. After checking that it's okay, then we screw in tightly. For the next part, we need to assemble the wiring. For that, we will be using the soldering iron, a wire stripper, and a screwdriver. Pay attention to the screwdriver. When we screw in the motor mount later, we will be using electronic screws, which are relatively smaller. Earlier, when we were using these machine screws for assembly, for these screws we used a larger screwdriver. However, now we are going to use electronic screws, so remember to use the smaller size screwdriver. Otherwise, you won't be able to loosen the screws. First, let's have a look. Don't put any batteries into the battery box yet, because we haven't finished with the assembly. If you put in batteries, you may short-circuit it by accident. Our battery is an 18650, which is a lithium battery, which is quite dangerous because there's a risk of explosion. We'll put in the batteries after checking the wiring. You may be curious, what are these additional holes for? There are 2 reasons for these. First, if we want to use Lego parts in the future, these holes can be used for the Lego pieces. These holes are reserved for the assembly of Lego pieces. Second, they can be used for wiring arrangement. When making this autonomous vehicle, wiring arrangement is quite a tiresome work. So we reserve these holes for simple wire arrangements. First, let's pass this wire through this hole and do a simple wire arrangement. We'll not trim the wires to an exact length because we have not yet decided how to organize all these wires. So it's not recommended to trim them yet. You can use your imagination and think how you'd want to organize them, but you need to fix them in place. Not only it has an organizing effect, but it also prevents the wires from getting pulled. Next, for the power switch. There's the VIN and also a GND. For the VIN part, we need to connect the red wire at VIN, while the black wire gets connected to GND. Let me show you an incorrect demonstration. If you connect the wires this way, it is wrong. Why? I'd like you to know why. I will be doing the following action. When you connect it, this wire is too thin. The connector is unable to fix it in place. After a couple of times, it will loosen and it will probably fall off. We need to find a way to make this wire thicker. The way of making it thicker is to use a wire stripper to strip the wire to be twice as long. Then we fold this over and add some solder to make it thicker overall. This way it will fix in place better. The advantage of using solder is that the whole wire will not loosen, but it can cause another problem, which is that soldered wires can split much easier because it becomes hard. You just shake it like this and it hardens. That is why I tell you that when you're doing the assembly, use these holes on the side and use the right wire length. Don't let it be too long. Get the right wire length so that when assembling it, there will be no movement and the wire will not break that easily. Otherwise, what happens to students in the middle of the lesson is that they have the wires getting shaken for a long period of time, they get split apart. So pay attention to this and make sure to get the right wire length so that the wire doesn't move around and get loosened. Let's strip out one specific length. Hold it down, then use the thumb to push it away. Then fold the wire over. When we're working with electronics, I suggest that you use a wire stripper. Why? Because there are not many wire strands. If you don't have a good wire stripping technique, it's easy to end up with fewer strands, so I suggest that when you're working with wires, it's best if you use a wire stripper, because it's already very thin. Next, we will add some solder. The soldering iron needs to be preheated. You can slightly contact the solder to check for its temperature. When it's ready, remember that every time you use the soldering iron, you must have the habit of cleaning the tip. I'm not planning on soldering anything else, I simply want to make it thicker, so I will contact it directly and let it touch the tip of the soldering iron. It doesn't need to be very thick. Making the joint a bit thicker is enough. When we assemble it later, it will be easier to fix in place because it is thicker. This way, it won't loosen when you're halfway operating the vehicle. In the future, you must pay close attention to this part for every lesson. Do not pull on them. You keep pulling on them during class and they can actually get split apart because there is solder on them, so they become brittle. Often pulling on them will eventually get them ripped off, so use your eyes to check if they are broken or loosened. Use your eyes to check and gently pull on them. Do not pull on them at all unless you suspect they may be loose. When fixing the screws, screw in fully and then twist them with force. Something like this. Try to organize the wires so that they don't move around. What I do is pass the wire through and make this part on the other side slightly longer, because there is still a bit of friction inside, so I will let the wire get fixed in place at this location. This way it doesn't move around so easily. This is enough. We'll work with the battery's wires next. In principle, we pass the battery wires through here. After that, we pass it through from below the vehicle. Like this. Then you can connect them in here. Because it is still quite long, so we can arrange them on the sides before pulling them up. Wind them around this hole before fixing them in place. Next, we'll cut this. We need to be careful when doing this. You can see that the DuPont line is revealing a metallic head, so we slightly push this down and cut it from the lower part of the metallic head. We can grab the wire stripper to cut it. If you don't have a wire stripper, you can use diagonal pliers instead, which get the same results. You can even see more clearly when using the diagonal pliers. Hold it at this lower part of the DuPont line's terminal and then cut it off. It will leave out a metallic piece. Why do we need to leave this part? The reason is because the power wire was made by soldering. After cutting this terminal, it already has a DuPont line connector, so we can cut this directly, leaving this part to connect it in. Some might ask, why don't we cut a longer section? Because if I cut it longer and then connect like this, part of the metallic section will be exposed outside, which is prone to cause short circuit, so bear this in mind. Also, let me remind you that when we're assembling the power wire, in principle, the metallic part must not be exposed once plugged in. The metallic part is the conductor part of the wire, which must not be exposed. The other wires are assembled in the same way. Use the diagonal pliers to cut off the lower section of the wire. Leave out these two metallic parts. We'll do the same here. We'll use the wire stripper to cut it. Hold the wire stripper at the lowest section and then cut it off. Use the wire stripper if you have one. Otherwise, you can use diagonal pliers. Use whatever tool is available at school. We'll cut these two sections only. Next, we are going to determine the left and right wheels. You can take a look at this. In principle, the front of the vehicle is determined by the way you operate it. This is called an omni-wheel. If this is facing forward, this section is used to make the mechanism part. If we decide to make the mechanism part, the vehicle faces forward and we define this as the left wheel. For the left wheel, we'll take a look at the inside wiring. The wire for the left wheel is purple and gray. The wires that you receive may be different, but it doesn't matter. Let's see what colored wires you have and use that instead. The most important thing is that you have to know which colored DuPont line should connect to which wheel. For our following lesson, we'll be using mechanisms. So for this wheel, we're placing the TT motor at the back and the Omni wheel at the front. The wire for the left wheel is the gray and the purple one. We'll connect this to A and B. Which one connects to A and which one to B? For this, we can check on the program later. We can use the program to check for the wheel's positive and negative rotation. For now, we'll roughly fix them in place. The wire is still too long, so we'll use these holes on the side as a buffer. We can also trim the wires so that they are not too long. This is too long, so we'll use the holes further away or coil the wire a couple more rounds. Remember that this wire shouldn't get stuck in the path of the battery removal. We still need to leave out some distance. Let's loosen this first. Counterclockwise to loosen and clockwise to tighten. And now we can plug this in. The electronic screw used here are actually harder to screw in. They break easily. Remember to use your index finger to do a downward pressure. Students often end up stripping the screw during this part, so be careful with this. Counterclockwise to loosen and clockwise to tighten. Remember to use your index finger to do a downward pressure. After screwing in completely, turn a few degrees more and it's done. We'll do the same for the other side. The wires for the right wheel can be placed at the holes on the right. You can divide this into left and right sides. The wires must be organized a bit. If you don't arrange the wires, the whole vehicle will be full of wires running wild, which is a common issue that happens with autonomous vehicles. Wires get unorganized. Try to place the wires at the size of the controller board so that when operating it, it looks much tidier. You can also use them as a buffer and use the friction of the buffer to hold the wires in place. The last section with the stripped wire can then be connected to the back. We can pull this more to the back. We will decide the polarity later on using the program. We don't modify this part for now. The right wheel will be connected to motor B, while the left wheel will be connected to motor A. The wiring is more or less like this. You can arrange the wiring so that it looks tidier and easier to work with. Hello everyone. What we are going to do next is this. Initially, the battery box was directly supplying the Node MCU's motor control shield. However, if Wi-Fi is not required during the operation process, the current supply is enough. If we need to add some more, for the Wi-Fi control step, this will cause a current overload in the Node MCU's voltage regulator, which can cause a crash due to overheating. If you need to use Wi-Fi frequently during this operation, I suggest that you add a voltage regulator to tone down the original 18650 battery's voltage and decrease it to around 5 volts. After 5 volts is supplied to the Node MCU, the voltage drop is not too much and less waste heat is generated. Now we will teach you how to make this voltage regulator pin. We'll be using a miniature voltage regulator circuit board, a double-sided pin, a DuPont line connector, and 2 plastic shells. Let's take out our diagonal pliers and cut out 3 pieces of this pin, because later on we will solder these pins onto the board. Later during the soldering process, please pay attention to this. We will be connecting it this way later. I will connect its positive terminal with the motor's positive terminal, and connect the negative terminal to the far right side to this GND part. When we're connecting this later, these 2 pins should look like this. Notice that our arrow is pointing upward, and below it, at the original power input part, we connect these metallic pin connectors to the outer part of the board. Let's place it like this for now. We'll use the soldering iron after preheating it. Before using it, remember to keep the tip of the soldering iron clean. When soldering this part, make sure that the soldering iron that we are using does not exceed 20 watts. 15 watts is better, and it doesn't overheat. Later when connecting it, you must be careful, because the circuit board is very small. So don't let it heat up for too long. I told you before that when soldering the TT motor, do not exceed 3 seconds. This definitely can't exceed 3 seconds. The faster you finish it, the better. Be quick with the soldering. Approach the solder, and then take it away. Then the other side. If you find it difficult to do it, you can ask your classmate next to you to help hold down the circuit board. Let's do this again. When soldering, first contact the soldering iron with the metallic pin and then approach the solder. 1, 2, 3, and then take it away. Afterwards, you can check the soldered part, whether it has turned into a small bump. But don't let it get pointy, it's better if it's a bit concave. During soldering, these two pins will get wide open, which is ideal. Why? Because when we fix this in, we'll give it an angle. This way it's more convenient to fix it in place. Next, let's take a look at this part. This G and D is the negative terminal. We will not do any soldering because these two negative terminals are interconnected and both are connected to ground inside the circuit board. We won't be using this ground part because later on this ground part will go straight into the system. Next is the positive terminal after voltage regulation, which is supplied from the left side. When doing this, we can solder the inner section. This way, it won't block the upcoming wiring process. In the same manner, hold down the workpiece, contact it first, then approach the solder. It should more or less look like this. Let's place the pins like this. Later, we would not use this exposed part after voltage regulation, this metallic head with the arrow. So we can cut it off. Be careful when cutting it because it will fly out randomly. So it's better to cover it with your hand, so that it flies towards the palm of your hand. And then throw this part into the garbage bin. Don't let it fly out. We're going to move on to the next part. We are finished with this section. Since there are two types of voltage regulator circuit board, I suggest that you directly buy the 5 volts one, because it's more convenient to use the one with 5 volts regulated voltage. If yours isn't a 5 volts regulated circuit board, you will need to adjust the voltage, so it's recommended that you buy a 5 volts regulated board. Next, we need to connect our original power supply wiring to a DuPont line and a female connector. We need to connect the original power wires, which are these red and black wires. We need to add on the DuPont line female connector and then join them together here. We will remove this. When doing so, you must cut off the power. By no means should you do any of this without cutting off the power. Next, we'll loosen the screws. If you are worried about short-circuiting it, we recommend leaving one end first and remove the other end first. Organize the wiring first. We'll take this wire and use the wire stripper to cut it. After cutting it, we'll choose the smallest wire stripping hole to hold it. We need to cut off around 5 millimeters. We'll hold the wire using the index finger and ring finger. Hold the wire tight, then use your thumb to push out the wire stripper. Slightly arrange the wire. This is the connector for the DuPont line. We'll take one of these connectors. To take this, grab diagonal pliers to cut down a section of it. After cutting it off, we can take a look at it. This will be connected like this. This metallic connector at the bottom contacting the red wire will wrap around the red wire. The copper part of the wire will be at the front end. Wrap around the copper wire as well. We will give an example of a correct operation later. We'll strip a DuPont line. Let's have a look. We are going to crimp the DuPont line section. Let's look at a factory-made sample. When we are working on it, we can use the factory-made sample as a reference to crimp the connector head. Let's first look at the plastic shell. The plastic shell and the metallic part of the DuPont line are held together by this thin plastic piece. Later, I just need to pull this thin piece up, and the metallic part on the inside will come out easier. You can pick a box cutter and then insert this under the plastic piece. After you do it, pull it up and take out this plastic shell with ease. When you remove it, you can see that this wire is fixed at 2 points. The first one is at the rubber insulators, and the other is at the metallic connectors. When we are doing the connection, we will do it in 2 sections. The first one is with the rubber insulator, and the other one is with the metallic part of the wire. Next, let's take a look at this part. Let's organize our DuPont line. Let's strip around 0.5 centimeters length of rubber insulator and place the wire at the smallest hole. After holding it in place, hold the line with your index and middle fingers. Then use your thumb to push out the wire stripper. Then you will get about 0.5 centimeters of copper wire. It should look like this. When connecting it, we'll use some tools. Some students may use pliers, but it's actually hard to get good results with them, so we recommend that you use specialized tools. There are 2 types of commercially available crimping pliers that are often used for DuPont lines. The difference between them is that this one will crimp one section at a time. First the rubber insulator, then the metallic wire. It will crimp based on the different hole diameters. This one crimps both sections at the same time, and it has a ratchet. This ratchet needs a full motion and it will not retract before doing so. I'm more used to this one, so we'll use this in our demonstration. First, we will choose a suitable hole. Remember that this has a ratchet. After you press it down, it will hold in position, and you'll have to press it down fully to retract it. Bear this in mind when you're using it. Next, let's take a look at this hole. The crimping pliers have 2 sections. The wire's diameter is slightly larger for the rubber insulator section. The metallic wire will be thinner. When we're crimping the wire, it should be something like this. The wire should look like this after crimping it. Sometimes it may be hard to place and crimp the wire because the connectors are slightly warped. You can bend them slightly inwards so that it's easier for the metallic parts to fit inside the crimping pliers hole. But don't overdo it. If you do, it will be harder to insert the wires later on. Let's do this one more time. Hold this position first, then insert the wire. When inserting the wire, make sure the rubber insulator also gets inserted. The hole we used is too small, so the rubber insulator part can't fit in. In this situation, either you pull it out or allow the connector to become useless because it has a ratchet and it's not possible to retract it, so your only choice is to crimp it fully. Basically, this part gets broken. We'll need to take another one. Use pliers to slightly bend them down. Don't overdo it, because later the wire's rubber insulator needs to fit in, so don't bend it too much. Let's crimp it again. This time, we won't do it too much. We got experience from the last one, so we won't overdo it again. After fitting it in, check it from the other side. You will barely see the copper wire. If you got the right length, you should barely see the copper wire on the other side. After you fix it in place, you can crimp it and then release. Then check if during the crimping process, the rubber section got crimped as well as the copper wire section. Since the power cord is slightly thicker, we'll need to fit this into the DuPont lined plastic shell. So you'll need to slightly trim the rubber insulator so that it fits in with ease. Let's take the two plastic shells we prepared earlier and fit the wires in. If it's not possible to pull the wires out after fitting them in, then this part is completed. We'll do the same for the other one. We'll do the same for this. We'll arrange the wires first, cut off the part you don't need, and leave out 5mm of copper wire. Use the thumb to push this out and slightly arrange the copper wires. In this case, it is a bit longer. We don't recommend it to be too long, because having it too long, it can interfere with the connection with the DuPont lines connector plug. It will interfere with the amount inserted, so it should not be too long. You need to get a suitable length. Next, we're going to pick a metal pin header. In the same manner, slightly bend the two metallic pins, but not too much, because if you overdo it, the DuPont line will not fit in. We'll crimp them together. We have fixed the DuPont lines connector plug into this location. Next, we will insert the wire that we stripped earlier. Before fitting the wire in, it should be arranged a bit so that it's easier to insert. See that the end of this copper wire is sticking out a bit. When ready, press down the ratchet with force to crimp it tightly and then release. It should look like this after release. Both the rubber insulator and the copper wire got crimped. Once it's done, slightly arrange the rubber insulator section so that it will be easier to place the DuPont lined plastic shell. It means that this is too thick, so we are going to tighten it more so it fits better. Clamp it tight and then insert it. If you can't pull it out, then it's completed. This part needs to be crimped. If there are no crimping tools at school, it doesn't matter. You can also get your 10mm long DuPont lines and pick a red one and a black one. You can also use this method and cut it in the middle. I have cut this into two halves for any two students who want to use them. We'll take both red lines and solder them together. Then you can use a heat shrink tube or electrical tape to insulate them. We can also use this method if we don't have any crimping pliers available. We can pick some DuPont lines and solder them together and then use electrical tape or heat shrink tube to insulate them. Let's do the wiring up to this point for now. Next, we're going to install this. When doing so, If we connect these two exposed metallic pins like this, the DuPont lines will be pointing perpendicularly towards the back of the car. We want them to be pointing upwards. We'll bend these two short metallic pins that were left out to a certain angle. We will take out our pliers. When connecting this, it is a 2.54 millimeters long DuPont line. So we need to bend about 2 millimeters perpendicularly. We'll bend this a little. In reality, if you're not sure how long 2 millimeters is, the connector piece that was left out when we were doing the soldering is around 2 millimeters. We'll bend it along its exterior and leave out a bit of spacing, but you can't leave out too little or you won't have enough for the connector. Bend it inwards. After that, use the pliers to bend it even more, using the edge of the circuit board as assist to bend it down and make an angle. Later we will fix the DuPont line onto this place. We'll do the same for this pin. When bending this, make sure you leave out about 2 millimeters. Bear this in mind. After bending, bend it down even more, using the edge of the circuit board as an assist to do so. In principle, this pin can't be worked repeatedly. If worked many times, it may break off, so you need to pay attention to this part. You must finish it in one go. If you bend it 2 or 3 times, it will break off, so be careful about that. We'll leave out these 2 pins. After we are done bending these 2 metallic pins in the back, we're going to install the board onto the Node MCU. The angle that you saw earlier, we actually made them slightly outwards, around 4 to 5 degrees. You can take this and compare it. When you place it on, the angle is actually not enough. It's a bit tight. That's why we opened it a bit wider, so you can take this and visually compare them. After comparing them, use the pliers to slightly adjust the pins that are not wide enough or overly wide. Slightly adjust their width. When you're done, you can use a screwdriver to loosen the screw. After doing so, we'll combine them together. After it's installed, remember to choose the right screwdriver size, because the screws used in here are smaller than the regular ones. So if you choose the wrong one, it's quite easy to cause the chipping of the screw head. Next, we'll turn this clockwise to tighten it. Remember to use your index finger to push it down while doing so. Once it's done, you can slightly shake it to see if it's fixed in place. We haven't finished with this part, so we're going to power this next. Before that, remember to check the negative is connected to negative, positive to positive. Fix them in place after connecting. Correction. Connecting the wires this way can get them pulled out easily, so we'll pass the wire through here, winding around the hole once, so that it won't loosen easily. In the same manner, we'll pass the wire through the hole once. Then fix it in place. Later we can use a zip tie to tie these wires together so that they are organized more neatly. After we have completed the installation, we first need to do a voltage testing and make sure that the regulated voltage has reached 5 volts before powering the device. Before this, let me remind you of one thing. There is a short circuit ring. Its function is that when we input the two voltages VIN and VM, by using the short circuit ring to connect these two parts, they can share a voltage. But at this moment, we're going to do things differently. What we're going to do is that we'll give 5 volts to the controller using a voltage regulator. The other part, which is the unregulated one, is the 8.4 volts supplied by the 18650 battery, which is directly supplied to the motor control shield's power output. We need to pay attention to one thing. We need to take out this short circuit ring. We can use pliers to take out the short circuit ring. Once the ring is removed, we can begin with the electrical testing. We can't send in power directly. You have already separated the voltage for Vm and Vin. Let's turn on the power. Once it's powered, we're going to test it because it seems that the light is not on, so we're correct. Next, let's take a look at this. The setup we are choosing is the 20 DC current. Let's first measure the power supplied by our two 18650 batteries connected in series. See if we can get the voltage we desire. Line dropped. The wire fell off, so we need to be careful. We'll pay attention to the positive and negative terminals. We'll measure here. The current voltage is 8.29 volts. Next, let's take a look at the regulated voltage, which is this one. This is its negative terminal, and this is its positive terminal. Our regulated voltage is 5.09 volts, close to 5 volts. This depends on the working setting of the voltage regulator, which is around 5 volts. After checking that it's okay, we'll turn off the power. Why? Because we'll be connecting wires next. Beware, whenever we are connecting wires, the power must be cut off. Let's take out another 10 centimeters long DuPont line. Feed the regulated voltage directly to VIN. And who is fed by VIN? It's the Node MCU circuit board. So pay attention, we will connect it to this place. We'll fix it in place more or less like this. Next, we'll turn on the power. The power supply to the Node MCU has been completed. Whenever you're working with this, or you often need to use the Wi-Fi function for your classes, it's recommended that you add a voltage regulator. If you're using the vehicle for a long period of time, it's best to add this regulator board, a stabilizing mechanism. This way the voltage gets more stable, which is better. I'll turn off the power first. Hello everyone. What we are going to do today is organize the wires of the motor, the sensors, and the ones underneath the vehicle. Otherwise, it looks messy. Also, when we want to remove the batteries, it gets complicated, so we will arrange the wires to tidy it up, so that it gets easier to change batteries later. You'll need to prepare a couple of zip ties. After arranging some of these lines, we'll zip them together. Let's first loosen these 4 screws. Then we flip this over. Then we turn it over. We'll pass the wires coming from beneath by the outer side of the rear copper pillar and extend it upwards. Let's tie this up first. Both the top and bottom need to be tied up to have a better effect. Do not pull the zip tie too tight at once. Pull it to a suitable length and check that the other side is done as well. Then tie them together at the same time. Then we put our... This is the current situation. The left side is in charge of the motor wires, because later the controller wires will be arranged at the right side, so the right side will be the area for the controller wires. So the wires from the sensors will be sent to the right side. Check the position for these. In principle, it's like this. Take your time and don't pull at once. After pulling it, some adjustments can be made. After confirming, pull it tight, like this. then the bottom part. If there are some students that don't have enough strength in their hands, you can use some tools to help you out. You can use pliers. This part is like this. We'll do the same for this part. The next part will be up to you. We'll be doing the infrared sensor wires. How many sets are there? For now we only have one, but in the future, if you have 2 or 3 sets, or even 5 sets of wires, we can use pliers to remove the old zip tie. Rearrange them, and then tie them together again. In the same manner, we will use 2 zip ties. We will place the wires on the outer side of this vehicle. It's better this way. You can use tools to help you fix this in place. Pull it to the tightest so that it doesn't move around. When you're done, grab a pair of pliers and cut off the excess section. Next, we will put back the controller board. Why do we leave out such a long wire? Because when we are designing our vehicle, we hope that for the front and rear parts, we can choose which end will be the front and which end the rear, depending on our application. So we'll leave out the wire so that when we need to do this in reverse, there's enough wiring to do so. Even though there's a lot remaining and it looks weird, but suppose that if you want to use this in other applications, you can turn around the controller. For example, you can install it like this. You can also turn it over and install it this way. That's why we leave out so much wiring. For example, right now we want to install it this way. We need to leave out a section to the side because we are going to flip this over. When flipping this over, it will be easier to remove the battery box. It's more convenient to slide out the cover, so we need to leave out enough wire length. For the wire length, we can look at it this way. It'll be like this, more or less up to this point, so that it's easier to flip over. So when we've confirmed the length, we use a zip tie to fix the wire in place. To be more secure, we can use screws to slightly fix the board in place. Because once you screw it tight, and the length is not right, we would need to remove and waste the zip tie. At this moment, I'm not really fixing the board in place, so just screwing in one screw is enough. When it's done, for this length we'll need it to go a bit like this. Then fix it in place. Reverse the zip tie. You can let it be a bit loose. It's okay for this part, more or less a suitable length. And let it be a bit loose. This will go well later when we need to change batteries. It'll be more convenient. Pull the zip tie tightly. We'll do the same for this side. For this part, since we have the battery box here, we'll leave out the wires for our battery box that will get directed up. We can plug in the wires and send the remainder of the wire down so that the top looks more organized and less complicated. This way, we only need this much wire length going up, so we'll reserve this much. For the bottom part, we'll use a zip tie to zip all this under. Zip this under. Pass through the zip tie. After that, make a curve with it. But don't tighten it. Wait until everything has been arranged. then pull it tight. If the power supply wire gets easily loosened, you can use a double-sided tape or hot glue to fix it in place. We will show a demonstration. Next, we'll do it like this, storing the wires underneath. More or less this length. Don't leave out too much wiring running loose on the outside. Use a zip tie to hold it all tightly. This part is more or less like this. It seems that we left this too loose, so let's pull this tight a bit more. This side as well. Then use the pliers. There's the head of the zip tie left here. You can move it facing down. Your hand might feel uncomfortable doing this. You can move the head to the other side. Next, we will connect these wirings back in place according to our wiring from last time. Take a look at this. We can also place the excess wire to the side, then use the zip tie to arrange it all together. But first, let's restore part of the wiring. Let's connect them back. During the wiring process, you can first fix in place the wires that doesn't require further movements. For some wires such as the sensors, we will change the sensor's connection depending on the different applications. So we will fix these wires separately. For the wire fixing, we can divide it into two sections. Some of them, once they're connected, they will never have to be changed. You can fix them all together in one place. For example, this one. We can fix this to the side. For aesthetics, we recommend fixing them underneath so that it looks more organized. Next, we are going to connect the sensor wires. We used an infrared sensor, and you can check the colors below. VCC is blue and GND is green. So we will connect the VCC and GND wires. Because the 5th and the 6th pins will be used for the servo, we will not plug them in there. This will depend on which course we will be using the servo for. The wiring must be done according to the course's instructions. Let's look at the blue wire. We will connect it to D0's positive and GND terminals. For DO and AO, DO is the yellow wire. The wire is a bit too short, so you need to pay attention with the wire length when you're connecting. Suppose you think it has too much pull, do not pull it by force. Cut the zip tie directly and rearrange it again. This is how it is wired. After the wiring part is finished, you can try this out for yourselves. Next, let's screw back the screws. Take turns to screw in the screws from the opposite sides and screw in tight. Do not screw it all at once. For the wiring that we just did, I would like to remind you that if the wires got a bit pulled, such as shown here, the plate holding the DuPont line will actually deform and it will affect its connection. If your wiring is a bit tense, the connection of the plate inside will be affected. So at this moment, you must cut off the zip tie and rearrange the wire in a way that the wire is loose to prevent the pulling of the plate inside. Don't omit this part because of laziness. If you didn't get this part done, you should cut off the zip tie. Then arrange the wires well. A suitable length should be given to the wires like this. Then reattach another zip tie. Basically, the wires should be loose so that the plate inside the DuPont line doesn't get interference. When it's done, cut off the zip tie excess. The wiring we're doing next is the 12C servo controller board. We will need 4 copper pillar. What is special about this is that the holes of this controller board are of 3 millimeters, maybe 2.8. However, when doing the actual assembly, if 3mm copper pillar were actually used for the assembly, the nuts cannot be screwed in, so we can only use 2.5mm copper pillar to screw them. The same goes for the screws and nuts. We'll use 2.5mm. First, let's partially assemble this part. We'll use the nuts and the copper pillar to screw this. We'll install the bronze pins at the 4 corners. For this part, we'll screw this in tight. The PCB holes have both types of design. During the assembly, slightly push the copper pillar towards the corner. The same goes for this one. Then screw this tight. When we screw this later, we'll use screws to fix this in place. Install the nut onto the board. You may have to screw it tight. If some of you don't have enough strength in your hands, you can use pliers for assistance. It's quite small, so it's hard to grab onto. You can use pliers because the nut on this side will be pushed out by the DuPont line plastic shell. In reality, it will be a tight fit in this place. It will get stuck in place and won't rotate. Use the pliers for assistance to forcefully tighten it. Then connect this board to this wooden adapter board. Remember that when installing this, these 2 holes will match the ones on the adapter board on the same surface. So this shorter part should face forward while these pins of the servo controller board should face backwards. When installing this, it should be this way. Bear this in mind, turn this over and screw in a 2.5mm screw. We can use our hands to screw in these 4 screws first, then use a screwdriver to fix them tight. Next, we will unscrew these 2 screws because the adapter board will be connected here. Let's remove the screws. Install the board as shown here. For a more convenient installation, you can place the screw here first, and then align with the holes. The space is quite small in there. This part is completed. We'll do more wiring next and connect the wires back to the board. Let me explain this to you. This servo controller board requires 2 types of power, one of which is the control power, so we will use a red and brown line to represent the control power. This is connected to VCC and GND. This can use the positive and negative terminals on the node MCU directly, so we'll connect this at the 2 locations at the end of this row, the positive and negative terminals of SD2. We'll connect it here and use the 3.3 volts controller power. Once it's done, you can see that there is a V plus here, which is the 5 volts voltage. We'll connect V plus with VIN. Next is SCL and SDA. We can pass the wire through here because the wires might interfere. We'll connect it here, SCL and SDA. Let's have a look. We'll connect SCL to D5 and SDA to D6. This is the wiring method for the servo suspension board. Hello everyone. The following class that we are carrying out is the installation of our robotic arm. Let's first look at the materials that we'll be using. We'll have two MG90 servos, as well as some plastic kits used for this class. We also have some screws. One 10mm long screw, and a regular nut, as well as a washer. Next, we have 7 12mm long screws with the same amount of anti-slipping nuts. Why do we choose the anti-slipping nuts? Because we hope that during our assembly, we will fix the moving joints to the limit. Why do we need anti-slipping nuts to accomplish this? There is a plastic part at the end of the nut. Once you screw in up to the plastic portion, it will have an anti-slipping effect and it won't loosen easily. This section over here will serve as a moving section. It's not too tight, but it's also not loose. When using regular nuts, you need to screw in fully in order to get a tightening effect. However, it's different for anti-slipping nuts. The second advantage is that it has an anti-slipping effect since it doesn't loosen easily. Therefore, it can determine the moving range and maintain boundaries, which can restrict the moving range of our linkages. Secondly, it doesn't loosen easily. So when we have applications where there is vibration, or we need to prevent loosening and restrict the range of movement, we'll use the anti-slipping nut. Next, let's take a look at this. We'll assemble the front part first. Take out this part, as well as the bar linkages. Let's assemble them first. We'll first take the linkage that looks different from the rest. This part will be installed onto the servo. Let's bring the screws that we'll be using closer. Let's screw this in first. After you screw this in, use this anti-slipping nut. It is hard to fix in. It will be hard to do it with your hand because it gives a lot of resistance to prevent the insertion of the screw, so you have to use pliers. Let's fix the nut roughly for now. After screwing a few turns and you feel that it's getting hard to keep screwing in, and it gets stuck, use the pliers. Clamp it We can leave out some space because this part will later be used for movement, so you don't need to screw in until it's very tight. You should leave out some space for ranging motion. You'll need to apply some force when screwing this. Remember to apply a downward pressure in towards the nut, otherwise it would spin around and slip. When your screwdriver is constantly slipping, there's no downward force, and you're only wearing the screw down. Bear this in mind, many students wear down their screw before getting it into position, so you must apply a downward force and ensure that you're turning the screwdriver. If you notice that the screw is not advancing, then you're doing it wrong. When you're done screwing, you can slightly move this piece around and check that it can rotate normally. At this time, you can see that there is still some spacing and the screw did not get into position. Use the pliers to push it outwards. Push it out. Then screw this again. It should be like this. The best effect is when the screw is slightly sticking out of the anti-slipping nut. While allowing to turn smoothly, the linkage isn't too loose that it moves around. Let's finish assembling this according to its assembling steps. Remember that the plastic section of the nut should match the tip of the screw. Bear this in mind when using the anti-slipping nut. Turn the screw in the beginning. You'll feel that it's quite easy to screw into the anti-slipping nut, but halfway through it will be hard to do so. When this happens, take out the pliers. Hold the nut and screw it tight. Remember to apply a downward force. Don't let the screwdriver be turning around while the screw is actually not advancing. This way we're continuously wearing down the screw head. Bear this in mind. For this case, this is slightly loose, which is acceptable because if it's too tight, the mechanism will not move smoothly. The screw should protrude about 1 millimeter out of the nut. That tightness would be ideal. The assembly should look like this. The movements are fine. Don't screw the linkages too tight or there will be some issues. You must pay attention to this part. If we screw too much like this, it's too tight. And the movement of the linkage is not as smooth. Let's loosen this a little. When you see that the screw is barely protruding from the anti-slipping nut, this situation is ideal. It's about 1 millimeter. Move this around. This can be adjusted later. We'll roughly assemble this for now. This part is finished. Next we'll assemble the other part. Let's pass these screws through first. After these two sections are done, and you can no longer use your fingers to further tighten the anti-slipping nut, take out the pliers, repeat the action just now, and keep screwing this in. You need to check while you're screwing to see if you've reached the desired position. Check if it's too tight. If so, later during motion, this will cause the servo to require much more force to move the linkage. This installation is not acceptable. Some sections of the 3D printed parts have a rough surface, so the tightness is not caused by the screw. You can let these plastic parts rub among themselves to smoothen out the rough surfaces. But first, you need to check if the tightness is caused by the screw or the rough surfaces. Don't rub the parts blindly. Let's keep screwing in. This part is mostly done. Next, we'll fix the last nut in place. Once the anti-slipping nut is fixed in place, then turn the screw in. We'll move this around a little. Its movement is quite smooth. If the plastic piece is causing its movement not to be smooth, let it rub a little. Don't let it be too tight due to overscrewing. If the screw is screwed in too tight, it will also cause damage to the plastic part. Let's move on when this is done. Next, we will fix the servo in place. We will use the original screw that comes with the servo. Some self-tapping screws will come with the servo's packaging. Next, we will install the servo on the inner side, which is in charge of lifting. When installing this, its wires can be fixed to the side. There's an open slit here where you can pass through the wires, allowing them to come out from the side. Next, we will fix the servo in place. Roughly install one screw first. Check that it's correct, then screw in the other screw. Tighten the screw at the other side. It should be more or less like this. Remember to screw this well. This one is a bit crooked. Loosen the screw and redo it again. Next, we will install on this other side. Notice that when we are screwing this, the output shaft of this motor is facing the opposite direction to the servo. When you install this, it shouldn't be on the same side, but opposite to the lifting servo. So bear this in mind when we're installing the claw mechanism later. There won't be an opening for this wire because the wire cannot pass through the side because it would interfere with the motion of the linkage mechanism. We'll pull the wires to the back so it comes out on top. I want to emphasize this. Pay attention to the servo's output shaft. If you install this wrong, it will be complicated to disassemble. The motor's output shaft and the lifting servo are in opposite directions. Next, we will install the claw of the gripping mechanism. We will first put on the cover. It will be fixed in place with a tight fit. Place a nut inside first. A screw will be screwed in later. Then push the cover down with force. It will get a bit stuck because it's a tight fit. There are two ways to fix the cover in place. For the first time, we'll use tight fitting. Next, we will fix the claws of the gripping mechanism in place. We need to include a washer. We'll pass this through. Then fix this in place. We'll assemble this up to this point for now, because we need to adjust the servo first before we install the rudder. We haven't written our program code yet. We can roughly fix it in place because you may be concerned that this small screw will get lost, so we'll roughly install this for now. However, there will be issues with the angle when we do it this way. We need to set the servo to 0 before we can install this for real. We'll install this rudder. When fixing this, there's an inverted U section. We'll insert the rudder in. The same goes for this location. The rudder is also inserted in. Pay attention to the screw. We'll remove it. The protruded part should be facing inwards, so this should be inserted this way. Because we're concerned that the screw will get lost, we'll fix the screw onto the servo's output shaft. We don't fix the rudder yet. We'll place the screw onto the servo's output shaft first. This part is the same. For the positioning of the rudder, we will calibrate it after uploading the program. Once we have everything assembled, we need to check whether our wiring connections are correct. We will first check the positive and negative rotation of the motor. Let's take out our smartphone and open the testing program that I taught you how to install in previous lessons. After we open the app, connect the smartphone with the board. Tap this. The smartphone is now connected to the Node MCU. We'll open our internet browser. Input 192.168.4.1 and press enter. Once we're connected, we will have several modes to select from. Right now, we need to test the motor's positive and negative rotation, so we'll choose the tank mode. In tank mode, we can control the left and right wheels. Let's control the left wheel first. Let's have a look. We'll slide this to the far right. You can see that the left wheel is doing a negative rotation. It's not turning forward. Let's return it to 0 and test the right wheel. Turn this way. The right wheel is also reversed. We made the wrong setup for both left and right wheels. I mentioned this earlier in class. Let's turn off tank mode. As mentioned earlier, the motor's positive and negative rotation is decided by the direction of the current. Both the left and right wheels have the wrong direction. We'll need to invert the wires to change the current direction, which will change the motor's direction of rotation. First, we will turn off the power. Please make the good habit of turning off all the power when adjusting the wiring. Let's swap the wires to change the direction of the current and control the direction of rotation. Fix them in place after swapping. This is for the left wheel. We'll do the same for the right wheel. We'll loosen the wires and install this back. Next, install the other wire back. Make sure that the metallic part of the wires doesn't touch and cause short circuit with other metallic parts. You must bear this in mind. Tighten the screw. When you're done, you can pull the line slightly and check if you've fixed it tight. Turn it back on after you've finished. Use the smartphone to reconnect with the board. Input the password. Our password is fixed. Don't change the password. We'll reconnect to the board and refresh the web page. Select tank mode. The password was incorrect. Once we've reconnected and refreshed the web page, we'll go in and select tank mode. We'll check again and see if the motors are rotating correctly. Let's have a look. Let's turn the left wheel. The direction is correct. We'll stop it, then test the right wheel. It's also correct. We can use tank mode to correct the direction of the left and right wheels. Next, we will install the robotic arm. Likewise, when we are working with this, the power must be cut off. When doing this section, we will do one thing. We will separate the signal line from the power line. We'll need to extract the orange wire. We'll grab a box cutter and insert its tip into the DuPont line's plastic piece and gently pull out the orange wire. We'll do the same for this line. After the lines have been separated, take out the DuPont line plastic shells. If you have any left, and use the same way to cut them open. Let's reconnect these two lines. The plug-in direction needs to be correct so that it prevents the wire from slipping out. We'll reconnect the wires. Next, we will assemble this vehicle with the robotic arm together. This will be assembled where the screw holes are matching. So we'll remove these screws. After that, we'll connect the wires. The one at the front should be connected to the power supply. For the power connection, brown is to ground and red is to the positive terminal. We'll connect the red wire to VIN, which will be at this location. While GND, which is connected to ground, we can connect the idle connector adjacent to it, since no signal will pass through. It doesn't matter. The same goes for this one. We'll connect this here and the power line will be connected here. This is also a VIN positive terminal and a GND negative terminal. There will be an idle connector pin. Next, we will do the positioning. We'll take this signal wire, which are in charge of the upward and downward motion, and connect it at D5. D5 is located here. We'll turn on the signals and reconnect to the board. Once connected, its default configuration for when we are connected to the board only when it is connected is for the servo is at the 0 angle position. Once the program is written in and powered, it will be at the 0 angle position. Next, we can adjust the servo with the lifting mechanism to the lowest position at 0 angle and fix this at this position. Remember to loosen the original screws. After the screws are installed, we'll take out our smartphone and choose the QC mode to perform our testing. We can control the angle of this item inside QC. We'll just rotate the servo and then let go. The advantage of having the initial setup to 0 angle is because when we power up our system in the beginning, the servo will turn to the 0 angle. If it gets stuck at an angle and cannot continue with the motion, the current will be greatly increased in order to change the angle, which will cause the servo to burn out. We need to be careful about this part. Next, we'll install the other servo. During our setup, we used the D5 pin, so we'll do the same. Let's free up D5 and then connect the wire. We'll first cut off the power and then install the wire onto D5. After you reconnect, you need to refresh the browser. We'll first let it be at the 0 angle position. Whenever there's a connection, the servo will first turn to the 0 angle. We'll assume the position this would be at 0 angle. We'll install this the other way around. It should be like this at 0 angle. The claw should be open. We'll install this once we're sure about it. The claw is at the open position and then we install the servo. Tighten the screws and you can let go of it. We'll test this and choose the QC mode. Next, once we've confirmed that it's in the 0 angle position, we'll assume that the claw is wide open at a 0-degree angle. After this position is confirmed, we'll fix the servo in place. We'll tighten the screws. Let's check if our servo is able to move. If you hear a sound, it means it moved. We'll reset the servo to the 0 angle position. Once it's positioned, this will be our initial position at its lowest. This will be our initial angle during our operation. We'll fix this at this position and take out the claw mechanism part. Push in the servo with force and check that it's the angle we want. Then place in the screws. We'll do an opening and closing motion. We're done with this. After this part is done, you should take some time to arrange this wiring. Next, we will connect this servo. We'll install the lifting and gripping mechanisms back. Next is this. The gripping mechanism should be connected to D0. We can base the connection on the wire colors that are shown. Red is in the middle, while brown and black correspond to here on the outer side. Next is the lifting mechanism. Next is the connection of this ultrasonic sensor. VCC is yellow and G&D is brown. Let's cut this open to have a better view. Yellow and brown. We'll be connecting these to pins D7 and D8. This VCC is connected to the VCC on D7. The brown wire is connected to the G&D on D7. The orange wire is connected to D7. The red wire is connected to D8. We should slightly organize the wires. These two wires. However, you should pay attention when organizing the wires to see any of them gets pulled during the mechanism motion. Don't arrange the wires and cause the mechanism to get stuck. It should be something like this. We can include a zip tie, cut off the excess, Be careful when cutting it. Only cut the zip tie and not the wires. It would be terrible if the wires got cut off. We're finished with this part.